good day, future engineers. You have already tried to discuss everything in the introduction. Let's start with our first problem. So on the left side of the screen, you have here, determine the natural frequency of the system below. So we have a system here na naa stiffness K1 and stiffness K2 and the system with a mass M. So this is a simple system with the following. So first, yung natabuhatan is we try to look no. If we try to see first, nga naay daghan stiffness diri, that is more than one. So, and then, we try to categorize, is it in series or is it in parallel? So, sa katong gipakita na ko nga video before, we have something like this, diba? We have two springs attached with and then a mass M. So, we have a stiffness 1 and a stiffness K2. So this one is in series. The other one here, we have something that looks like this. So two springs again attached on a mass. And then we have here stiffness K1 and stiffness K2. The second one here is in parallel. Now how about this one? Kani siya, this looks something like this, diba? But actually, this is a parallel. Kaya wala man nagsulod ang duha ka spring. No, it is natungan siya sa ato ang mass system. So this is a parallel. Next, after determining, so sunod no pag solve niyo na dali na jud kay kabalo naman mga parallel na og series matic na dito. Next button is if we try to draw the free body diagram of the mass M, so natay kono something like this. So you have our mass M, and then let's say, gi-move na to si mass M to the left. Let's say that is our positive X. Okay, diya man tayo ang motion. Of course, his stiffness, it resists deformation. So that the forces acting on the spring is against the deformation. So we have our force 1 here. Now that is equal to K1 X1. And another force 2 here equal to K2 X2. Next. So may next na to ani. So if you remember the general equation of motion, m double dot x plus c dot x plus kx is equal to, since this is a free vibration, that is equal to 0. So again, mo kalibog ganong x na sad, ganong u, parehara na sila, basta kasabot lang mo. This is the response acceleration, response velocity, and the lateral displacement. So for this one, there is no damping considered. So we are left with m double dot x plus the stiffness times the displacement or deformation is equal to 0, or x double dot plus k over m x is equal to 0. Or applying the relationship no sa katong natural frequency nato, we have double dot x is equal to omega squared x is equal to 0. So yun, determine the natural frequency of the system, this one. So if you remember nung ang omega, the natural frequency is equal to square root of k over m. So dali ra gid kay ni siya. But our k here, since naman tayo duha ka stiffness, we have the stiffness K1 and K2. Therefore, atong K diri is the equivalent stiffness. So, saan mo napakuha na to sa equivalent stiffness? So, mula ito siya i-determine first if it's in series or if it is it in parallel. Since this is in parallel, our equivalent stiffness is just equal to K1 plus K2. So, dali na tayo. Our natural frequency for this system is just equal to square root of K1 plus K2 over m. O, diba? No sweat. Dali na kayo. Next. Okay, how about this one? Determine the natural frequency of the system. Okay, no? If you try to look, this is in parallel. K1 and K2 are in parallel, and then this one is in parallel also with K3. So, if you try to draw the FPD, no, you will have your mass here, and then, let's say, ato siyang ipa-move on that side na sad, o, diba? That is our positive X. So, sa metabo, si spring always in, the force is always opposite in the direction of the deflection or deformation. So, we have our force 3 here is equal to K3x3. And then, we also have our force 1 and force 2 here. So, our force 1 is equal to K1x1. And force 2 is in K2x2. Next. Again also, since this is, there is no damping here, C is equal to 0. So, automatic na, no? We have our natural frequency, which is equal to square root of the equivalent stiffness over M. So, ato ang equivalent stiffness diri, since this is in parallel, that is just equal to K1 plus K2 plus K3. So, automatic, the natural frequency of the system is just equal to the square root of K1 plus K2 plus K3 over the mass over mass. So, mura. CCO.